want you to try something. Open a new tab and type in a question. That split second you had to wait, it felt like magic, didn't it? But it wasn't magic. It wasn't magic at all. It was actually metal. To answer that one simple question, a signal had to travel through the most complex machine that humans have ever created. A machine that consumes rivers of water, burns through enough energy to power an entire city. We usually talk about the cloud like it's fluffy, weightless. But today, we're going to look at the ground. We're going to trace the physical activity of artificial intelligence. We're going to dig deep to the mines of North Carolina, walk through the factories in Taiwan, and stand inside the deafening data centers across the world. This is AI Deep Dive, and get ready to learn. If you want to make apple pie, the first thing you have to do is invent the universe. If you want to build an AI infrastructure, you have to start with a rock, specifically this rock. This is quartz, and it's in the purest form possible. It has to be this way, because otherwise AI wouldn't work. And if this one mine shuts down, the entire AI revolution, it doesn't just stop. It's over. We melt this rock down to a single perfect crystal called an ingot. It looks like a futuristic obsidian log. We slice it thinner than a human hair. This is the canvas. But to paint on it, we need a brush that costs more than a fighter jet. Welcome to Veldhoven, Netherlands, home of ASML. You've probably never heard of this company, but they are arguably one of the most important companies in the world for this AI infrastructure. They build this. This is an extreme ultraviolet lithography machine. Here's the problem. To make an AI chip, we need to draw small switches. How small? Imagine a virus. Now imagine a switch so small you could fit thousands of them inside that virus. And you can't use a pen. You can't even use normal light. The light waves are too fast. You need EUV light. ASML generates this light by blasting a droplet of tin with laser twice, exploding it into plasma hotter than the surface of the sun. Without this machine, there is no GPT-4, there is no NVIDIA, there is no AI. So we have the wafer and we have the machine. Now, we just need the blueprint. This is where the king of the chip, NVIDIA, enters. Jensen Huang, CEO of NVIDIA, saw the future before anyone else could. He realized that for AI, we don't need a smarter chip, we need a wider one. A CPU, or central processing unit, the chip that is in your laptop, is like Einstein. Yes, the really smart one. It's brilliant at doing one really difficult task, but AI chips are different. AI isn't a hard math problem. It's a billion easy ones, all at the same time. That's a GPU, or graphics processing unit. It's not Einstein. It's a stadium full of math students. NVIDIA designed the H100, the Hopper, to be the ultimate stadium. But here's the twist. NVIDIA doesn't actually build them. They just dream of them. The blueprints behind everything. To build them, they have to mail the design far across the oceans. This is TSMC, the Taiwan semiconductor manufacturing company. If NVIDIA is the architect, TSM is the construction crew. This building is the cleanest place in the entire universe. The air inside is filtered to be 1,000 times cleaner than a hospital operating room. A single speck of dust here would land like a meteor, destroying the entire chip. But lately, the problem isn't the chip. Think about it. A super genius brain is useless if it has amnesia. The GPU needs data constantly, so companies like SK Hynix are building high bandwidth memory, or HBM. They take the memory chips and stack them like pancakes and glue them right next to the brain. This glue, called packaging, is actually the biggest bottleneck in the industry right now. We have the chips, we just can't glue them together fast enough. Okay, so the chip is done. It's shipped. Now, where does it live? It lives here. This is a NeoCloud data server. Companies that specialize in NeoCloud services like CoreWeave or Nebuous are building them.
Andy Power, yes, that's his real name, is the CEO. We are literally standing in the power center for the cloud right now.
That's right. So
that's the sound of 20,000 fans fighting a losing battle against heat. These chips run so fast, they would literally melt themselves. That's why the newest factories, like Elon Musk's Colossus, are switching to liquid cooling solutions. They submerge the entire computer in fluid. It looks like sci-fi, but it's just thermodynamics. These aren't just server farms anymore. They're compute power plants, and they have a hunger that is starting to scare people. Here is the hard truth. We can dig more mines, we can build more factories, but we can't easily build this. Single ChatGPT query uses 10 times the electricity of a Google search. We are entering the gigawatt era. Microsoft is restarting the 3 Mile Island nuclear plant. Amazon is buying nuclear reactors. The constraint on your future intelligence isn't actually the silicon anymore, it's electrons. We are literally terraforming our energy grid to feed these ginormous machines. So let's look at the map one last time. Sand from North Carolina, lasers from the Netherlands, designs from California, fabrication in Taiwan, memory from Korea, power from nuclear reactors across the world, all to answer the one question you typed at the start of this video. We are building a second species of intelligence, physically piece by piece. It is the largest industrial takeover in our history, and we are just turning the key. This has been AI Deep Dive, and I hope you guys truly understand at what scale technology is being transformative right in front of us. If you're new, please subscribe. I hope you enjoyed the video, and I'll see you next time. Goodbye.